Happy Friday, everybody. So today we're going to review verifying whether a point lies on the line. And in fact, this is related to the table of values which we worked with earlier on in the semester. But before we move on to that, let's review what we did yesterday. And yesterday we talked about determining the equation of a line given the graph. So let's work with this graph here. I know that my equation in slope-intercept form, which is the form that we've been dealing with so far, is y is equal to mx plus b. And I know that m represents the slope of the line, and I know b represents the y-intercept. Well, right away, I have one major piece of information about this graph. I know the y-intercept. And in fact, the y-intercept is at 0, 4. So I know that my b value is going to be positive 4. So I know it's y is equal to, I don't know the slope yet, so I'll write that as m still, m times x plus 4. Now the only thing I'm missing is to find my slope. In order to find the slope, I want to know the rise over the run, or the change in the y value during the change in the x. So let's work with the rise and the run. I need 2 points that fall nicely on the line. So the y-intercept is always a really nice point. And then coming down here, I could use this one, or let's just use this one down here, right there. So I need to know, going from one point to the other, and it doesn't matter which point I start at, but I'll start at this point here. I need to get from here to here, going either vertically, up or down, or horizontally, left and right. So I'll start here, and I'm going to go 1, 2, 3, 4, 5, 6. So I went up 6, so my rise is positive 6. And then I'm going to go to the right, 1, 2, 3. So my run is 3, and because I went to the right, it's a positive 3. So my slope is 6 over 3. There is something wrong with this, however, because it's not in simplified or reduced form. So I need to find what's a common multiple to 6 and 3, and it's 3. So I'm going to divide both the numerator and denominator by 3, and I'll get 2 over 1, which I can just write as 2, because 2 divided by 1 is simply 2. So what's my slope? Well, my slope is 2, positive 2, so I can get rid of that m, and I can write 2. If it was on the left, would it be negative? What was on the left? If the line was on the left, you'll have to clarify and I can answer your question. Let me erase this. So what's our equation? Y equals 2x plus 4 is the one we're working with. If the point was going left. So it actually doesn't matter. Yeah, if we were moving to the left, if the run was going to the left, it would be negative. So actually, to answer that question, let's find the slope again, but let's start with this point here and move on to this point here. So I'm going to start here, and in order to get here, I can either go down to the left, or I could go to the left and down. It doesn't matter which way I go, but let's go down first because I always like to do the rise first. So it's rise over run. Okay, well, that pen is terrible. And we'll start here. My rise is going to be 1, 2, 3, 4, 5, 6 down. So my rise is going to be negative 6. And my run is going to be 1, 2, 3 to the left. And because it's to the left, it's a negative 3. So my slope is negative 6 over negative 3. Whenever I have a negative divided by a negative, I know that's a positive, so I can make the whole fraction positive. And then when I reduce it, I get 2 over 1 again, which is just 2. So I get the exact same result. It doesn't really matter which way I get there. So now my question is, I want to know if a particular point lies on this line. So if I give you a point, can you tell me whether it's on the line or not, even if you didn't have the graph? Now I do have the graph, so if I say, hey, is is -6 and -6 on the line, well, we could just simply go to the graph and we go, okay, -6, -6. Nope, that's not on the line. That doesn't work. But we don't always have the graph. And as lines get more complicated, we need different methods of determining whether the point lies on the graph. So let's say that we don't know whether -6 and -6 is on the graph. We don't have this graph, and we want to find out through the actual equation itself. Well, an equation relates two pieces of data. It relates the x values with the y values. And if the x value in this case is -6, well, then the y value should also be -6. And to demonstrate that, I can say, okay, this is y is equal to 2, but instead of writing x, I'm going to replace x with -6 because I want to know what the y value is when x is -6. So I'm going to put in -6 plus 4, and then I'm going to solve this to determine what the y value is. So let's see. So 2 times -6 is -12 plus 4, and -12 plus 4 is -8. That is what the y value is when the x value is -6. So one of the points on the line is -6 and -8. That is not -6 and 6, so it does not lie on the line. There's another way of doing this. If I want to know whether -6 and -6 lie on the line, I can actually replace the x value and the y value in the graph and see if everything balances out. So in this case, because x was -6, the right side equals -8 and the left side equals -8. So the left side equals the right side, everything balances out, the equation is balanced, everyone's happy, and the math works. But in this case, I know -6 and -6 don't lie on the line, so let's use it to test this system out. I'm going to replace both the y by -6, and I'm going to replace the x by its -6. So -6 here is equal to 2 times -6 plus 4. If this point lied on the line, when I sub them into the equation, the left side should equal the right side. So I'm not going to do anything with this left side. This left side is equal to -6 because -6 is already isolated. But let's simplify this right side. So 2 times -6 is -12. It's 4. -6 is equal to -12 plus 4 is -8. That doesn't work. Those don't equal each other. And so that is not a point that lies. We can also find points that do lie on the line using a table of values. So let's pick another equation. Let's say y is equal to 1/2 x minus 2. And let's say I want to know some points on the line. I want you to find some points on the line. I want to know some of the coordinates that exist. We can do that by picking a bunch of random x values and finding out what the y values would be. So let's say I want to know what the y coordinate will be on our graph. I want to know what the y coordinate would be when the x is 0. Or maybe I want to know what the y coordinate is when the x is 1. Or maybe I want to know what the y coordinate is when the x is 2. In order to do that, I can use my equation, and instead of writing x, I'm going to sub x in for what I want to know about the value. So I want to know what y is when x is 0. I'm going to sub 0 in for x, and then I'm going to solve it. So y is equal to 1/2 times 0 is 0 minus 2. So y is equal to -2. So what is y when x is 2? Well, it's -2. Or sorry, what is y when x is 0? It's -2. So that's definitely a point on the line. The point on the line is 0, -2. So that would be something right down here. I want to know what y is when x is 1. So I would do the same thing, but I would replace the x with 1. So I'd put 1 in here. 1/2 times 1 is 1/2. And 1/2 minus 2 Well, in order to do this, I need to create a fraction in the second term. This is 2 over 1, but I need the denominators to be the same, so I'm going to multiply this whole fraction by 2. I'm going to get y is equal to 1/2 minus 2 times 2 is 4 over 2, and then 1 minus 4, that's going to give me negative 3 over 2. So what is y when x is 1? Well, it's negative 3 over 2. All right, well, what if they give me a point and I want to know if it falls on the line? So let's say I'm given so let's say I'm given the point 4, 4, and 0. So I want to know if that point, which happens to be an x-intercept, but I want to know if that point lies on the line. And to test it, I'm just going to plug it in. So the y value here is 0. So I'm going to, instead of writing y, I'm going to write 0 is equal to 1/2, and then the x value is 4 minus 2. And now I'm going to simplify it to see if the left side equals the right side. So the left side is 0. I don't have to do anything with that over there. 1/2 times 4. Well, I'm multiplying 4 by 1/2. I know what half of 4 is. I know that it's 2, so I'm just going to write 2 minus 2. 0 is equal to 0. That works. The left side equals the left side, the right side. The equation is true, and therefore 4 and 0 is actually a point on the line, right over here. Well, let's test 7 and 1. So same thing, and this time actually I'm just going to leave the y as y. 1/2, I'm going to put in 7 for x, because that's the x value, and I'm just going to see if when I solve this, if I get a y value of 1. So y is equal to, this kind of sucks, so half of 7, 1/2 times 7, well, you know, I could turn 7 into a fraction and put it over 2, but I know that half of 7 is 3.5, so I'm just going to put 3.5 minus 2. Y is equal to 3.5 minus 2 is 1.5. That's close, but that point is 7 and 1.5. That lies on the line, which means 7 and 1 don't lie. Because when x is 7, y is 1.5, and not. Is it important to use fractions instead of decimals? In a question, I will always ask you to use fractions, but the truth is, no matter what you learn in math and what grade you're at, the expectation is after grade 8, you can always do it with fractions. So you should be comfortable enough with fractional operations to be able to do pretty much anything. So the more you practice it, the better you get. So there'll always be some questions that require fractions, but when we're dealing with linear equations, it is pretty standard to write things as a fraction. Now, there's a difference between the types of fractions that we like to represent as fractions. And what I mean is the difference between rational and irrational numbers. Rational and irrational. So rational numbers are ones that either end eventually, so rational numbers end, or they either end or go on forever with a repeating decimal, so with a repeating pattern. They either end or repeat. So an ending rational would be like 3.265. It ends there. There's nothing past here. We didn't have to round that number. That's the whole number. It is a decimal, but it ends. Or it could be something like a 0.333 repeating forever. So even though this goes on forever, it's predictable. We know that it's always a 3, and so these are rational numbers. Rational numbers, it's okay to represent them as decimals because we don't have to round them in order to do that. Irrational numbers, on the other hand, Irrational numbers are those that go on forever. The classic example being pi. So they go on forever. So pi 3.14, and then we know that it goes on and on and on and on and on and on and on. Every number is different. Somebody actually won a Nobel Prize for determining the smallest decimal of pi. So it's kind of a big deal in mathematics. But an irrational number is one that it can be represented as a fraction, but it cannot be represented as a decimal without rounding it. So if what we're working with are irrational numbers, it is always good policy to write them as a fraction, because as soon as we have to write them as a decimal, we have to round them. Unless it's asked for in the question. If I'm asking for how many miles would it take to get somewhere, if we're talking about things in units like lengths or measures like weights, it's okay to turn it into a decimal. But if we're talking about absolute numbers, pure numbers like we do in mathematics, if it's an irrational number, it's nice to write it as a fraction. In this particular case, 1/2 times 7, I know that that's going to be 7 over 2, but I was able to write it as a decimal because it's actually a rational number. The result is 3.5. But if it was a fraction that's irrational that goes on forever, it is good policy to write it as a fraction, because then I don't have to round it, and it's a more precise way of demonstrating the number. I hope that helps. I'm going to finish marking all the, I don't really mark them, but I'm going to finish reviewing all the Google Forms. We do have approval to use Google Meets or Microsoft Teams next week. I think I'm going to use Meets. If you could do me a favor, if you could try to get on Microsoft Teams and see if you can log on just in case, because things can always change and they could restrict us from using Google Forms or Google Meets. But hopefully we can do that. It'll be the same policy as before. Most of you will have your mics and your camera turned off. If you want to ask a question, you can turn your mic on, but we'll go through all those procedures next week. Obviously, you don't have to be there to attend. It is going to be a tutorial, so you can come in to either get some help or ask some questions or just see what we're doing. But I'll post all the videos up as soon as I'm done. So that having been said, good luck, stay safe, have a great weekend, get some rest, and hopefully I will see everybody on Monday.